Guys, you get to hear me again. It's Miss Griffin. We're looking at Unit 8, Skill 4, finding missing coordinates. Sometimes you're going to be asked to find one missing coordinate. Sometimes you're going to be asked to find two missing coordinates. So your essential question is, how do we determine the values of one missing coordinate or two missing coordinates? Fabulous. Pause it so you can write it down, please. So we're going to start with finding one missing point. So that means like they give you a quadrilateral and they're missing letter D if it's A, B, C, D. Or they give you math and they're missing the letter A if it's M, A, T, H. Okay, so you're missing 1 point in total. And the steps are here listed, but I want to talk to you about it by going through an example. Just also please make note that the exception to these steps is if you're looking at a trapezoid or an isosceles trapezoid. So you would do the opposite of step 2, which you have no idea what step 2 is because you haven't read it probably. But we're going to go through this process, and then you have a practice problem that has a trapezoid on it. So when you get there, if you get stuck, let us know. Quadrilateral ABCD has vertices A, B, C, and D. Wow. Determine the value of x. Notice that there's an x right here in D. That would make the quadrilateral a square. Okay, so I know it has to turn out to be a square in the end. That's pretty cool. But this square has letters A, B, C, and D. And notice that it goes in an order. A goes to B, which goes to C, which goes to D. And yes, that order matters. So take a second to plot those points with me. Over 0, up 1 is A. Make sure you label. -3, -1 is B. So left 3, down 1 is B. C is left 1, down 4. And we don't know where D is. I know that the Y value is -2, but we're not even going to plot that. So now I'm going to connect A to B and B to C. And then eventually D is going to be somewhere in this realm, because that's how I'm going to close this up to make it a square. But I don't know where it's going to be until I do a little bit of investigative work. Sounds pretty cool, right? So we've connected A to B to C. Now we need to take and connect C to D. C to D. Well, C to D is going to go in this direction, which means that we also have B going towards A. So we need the slope of B to A. All right, well, easy enough, right? Oops, I didn't mean to turn that into the word slop. Okay, so to go from B to A, so to find that slope, we need to do change y over change x. Or in other words, just look at your graph. How do you go from B towards A? It looks like we have to go up 2, and I'm going to write this down as I speak it, up 2, and right 3. Up 2, right 3. So now I repeat that. I go from C towards D, up 2, and right 3. And notice that I'm actually literally drawing it on my paper. So that means that point D gets plotted right here. Because if I were to connect it, and I always use dotted lines to connect my last point so that I know what was given versus what did I find. D is now located at 2, -2. So now the x coordinate is here. X equals 2. That's your final answer. I know this seems a little bit weird, but if you just use the order and slopes, then you'll be fine. Because remember, opposite sides are parallel in a square. And same with a rectangle and a rhombus and a parallelogram. Okay, so start by plotting an example 2, M, A, and T. So we have M at 4, 2. A at 6, -2. And T at -2, -6. So I'm connecting these, and notice that it says that it's a right triangle MAT. So we do need to connect it to make it into the triangle, but don't forget, it's asking us to make quadrilateral math a rectangle. So we go M to A to T, and then T to H. So we want to be able to connect T towards H, because that's the next step. We have M, we have A, we have T, then we got to get to H. So we need whatever's going in the same direction. So when I look at the graph, I need T towards H to go this way, which means I need A towards M because they're in the same direction. And again, we're thinking about the slope or the direction of it. So to go from A to M, we have to go up 4. So I'm going to, again, write this down, up 4. And then left 2. Left 2. So now I'm going to repeat that from T because, again, we're going T to H. So I'm going to go up 4, draw it right in, and left 2, plot the point, call it H. So now H is located, and again, you can connect with like little dotted lines to make that rectangle so you can see that it is in fact a rectangle. And H is located at -4, -2. And you box that in as your final answer. So that's how to find one missing coordinate, but now we're going to take a look at the backside and find 2 missing coordinates. It's slightly different in the process, so we're not going to use this whole like slope thing as far as parallel slopes go, but we're going to look at perpendicular slopes. So flip it over when you're ready. So here it says missing 2 points. If you're missing 2 coordinates, you must think about the properties of the shape, namely the diagonal properties. Because in the question that we've seen in the past, they gave us, say, a square, and they gave us this point and this point, being a diagonal. So we have to know that the other diagonal in a square is perpendicular to it. For example, squares and rhombi, rhombuses, plural is rhombi, have perpendicular diagonals, while rectangles have congruent diagonals. So in this first example, example 3, it says square geom. The coordinates of G are 2, -2, and coordinates of O are -4, 2. So we're going to plot those and label them. +2, -2. And then we have O at -4, +2. So we have G and O. So what they gave us was a square with G in the bottom right and O in the bottom or in the top left. And we need to find E and M. It doesn't really matter where we label these ones, we just know that they're in the opposite vertices. So they gave us OG and we need to find EM. And if you draw in those segments OG, which we can actually draw in on our paper, and just on this little sketch here, we see that they are in fact perpendicular. So we're going to write a little note that the diagonals are perpendicular, which means that we need op, recip, slopes. So we're going to find the slope, change y over change x, of OG. So when I find my slope, you can either do it with the coordinates or you can do it on the graph. For me, it's very easy to do it on the graph. You go down, you go over. We're going down 1, 2, 3, 4, so -4 over, and we're moving to the right 6. So then I'm going to reduce it, because we always reduce. It's -2 over +3. So my perpendicular slope, remember that means to flip and negate, is 3 over 2. And we're going to do this from the midpoint. Okay, so I know that sounds a little bit weird, but if I go from the midpoint, I'm going to go up 3 over 2. And then in the opposite direction, I'm going to go down 3 over 2, and that will get me E and M very easily. So I find the midpoint just by looking at this. There is a formula, and you can use that, but you can always do it just by looking. I know that I went down 4 and over 6, so now I got to cut that in half, go down 2 over 3. I just need to adjust my line real quick because the iPad was not letting me draw a nice straight line in here. So make sure your line's straight before you do this. But anyways, we said that we have to cut this 4 over 6 in half, so now I have to go down 2 over 3, and that plants me right here. There's my midpoint. So now I'm going to go from that midpoint and use my new slope, 3 over 2. Up 3 over 2, plot. Down 3 over 2, plot. And I'm going to call one of them E, the other one M. If you want to draw on your square, I know your paper's probably looking a little bit crazy, you can see very clearly when you connect them that you have all 4 points and it makes right angles. And those diagonals are perpendicular. So my coordinates, E, could be the one at 1, comma 3, and m could be at -3, -3. And I box that in as my final answer. You are allowed to swap E and M. It doesn't matter which spot they go in, because you could read this as the way that we wrote it, or G, E, O, M, in the opposite direction. It doesn't matter. So I know that was a weird process, but we're going to repeat it once more, and then we're going to do rectangles. So we have a rhombus, which is just like a square, but it's tilted. And they give us J, and they give us L. So I'm going to plot those 2, 8. And 8, 4. And then I'm going to connect them, and you should connect them using a straight edge. So they gave us JL, and we are looking for K and M. And again, if I draw in that diagonal, I see very clearly that they're perpendicular. Diags are perpendicular. So again, we need oprecip slopes. I'm going to do my change X, change Y table so that in case you don't like the graphic option like I used last time, you can just do the little table here. And I'm going to use my points to 8 and 8, 4. So again, I could have done this up top, but I chose not to. 2 minus 8 is -6. 8 minus 4 is +4. So my slope here is 4 over -6, which reduces to -2/3. I promise you they're not always going to turn out to be -2/3. It just happens to be the numbers we had here. So now my perpendicular slope again changes to +3/2, and we do this from the midpoint. Because if I do it from the midpoint, then it will allow me to get to K. So up 3/2. Now I got to find that midpoint on this segment. So if you remember, we went down 4/6, so now I have to cut that in half, down 2/3, just like our slope was. Find that midpoint, and now use the midpoint to go up 3/2, plot. Down 3/2, plot. Okay, so you're making this like funky little S thing. Okay, because you're going up from the midpoint and over, down from the midpoint and over. So we have K and we have M. And I box this in, connect them all. And you're probably like, wow, that looks like a square, not a rhombus. Yeah, you're right. It does come out to be a square, but a square is a very special rhombus. But it doesn't matter because it does say rhombus, and a rhombus is just, well, a square is just a rhombus with right angles. So we're going to state our answer. We have K at 7, 9, and M at 3, 3. Okay, so our final answer, 7, 9, and 3, 3. And again, the K and the M could be flip-flopped. Now we're going to take a look at this rectangle. They give us R and T, so I'm going to just sketch a rectangle and I'll label it eventually once I plot. We have R at 6, -1, and T at -5, +6. And I'm going to connect them again, use a straight edge. So here I have T in the top left, R in the bottom right, and I connect it. If I draw in the other diagonal with S and P, they don't make right angles. But what I do know about the diagonals is that they're congruent. However, it's going to be a little bit tougher to show congruence because that would be length, and making something of the same length would be kind of difficult to do graphically. So what we can do, though, is think about how we know opposite sides are parallel. Here and here is parallel to here and here. So if not only are they parallel, they're also congruent. So if I can find out how far over and down I need to go, then I can kind of sketch in on the opposite end to get S and P. So I'm going change Y over change X over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's my change Y. And then my change X, I'm going down 3, 6, 7. So I want to do the same type of thing to get the opposite side. So I know that right now S is going to go here, but I have to go over 11, and instead of going down 7, I'm going to go up 7 to get P. So this one's not tilted at all. It's actually vertical and horizontal, however you want to call it, because we know that there are right angles formed by a vertical and a horizontal line. And we know that opposite sides are congruent because they have the same length. This was the length of 11, this was the length of 11, and then again we have 7 and 7 here. So I think that rectangle is the easier one of the 3 options that we've been doing, but rhombus and square are the ones they're probably going to ask you on a test. So you want to get this method from up above stuck in your head more so than the rectangle, because it's very, very easy to make the rectangle. You just make it into that box. Okay? If you have any questions, let your teacher know. Go back and refresh your memory on how to find just one coordinate before you do the practice problems. And then you'll also need to, again, know how to do rhombus and square in order to be successful on your CFU. That means you got to practice first. Okay? Let us know if you have questions. Adios.